Hey boys and girls, it's week 5 and we're finally not going to do any drawings. This week we're going to look at a bit more theory and it's going to be about machines that use pneumatics and hydraulics. So let's start with pneumatics. What is pneumatics? It's machines that work with gas. Now before you continue with this video, I want you to take a syringe and I want you to, with the air inside of it, put your finger at the bottom, like this picture, and I want you to push down on it. What do you see happens? You would see that when you push the syringe, the air particles will be pushed down. So for example, if you push and you push, the air particles get trapped until you can't push anymore. So the syringe has some form of movement. So that is pneumatics. Hydraulics is machines that work with liquids. Now I want you to take that syringe, I want you to put some water in it, and then I want you to push down on it again and see what happens. Basically what happens is nothing. You can't push the syringe down because there's much less space between water particles. So when you push, they immediately push against each other and you can't push it down. This is really beneficial when we think of machines because when you push on one thing, it will immediately move on the other side. Where if you take gas inside a syringe and you push against each other, the one will move and the other one will still take a little bit of time before it moves. Now, I want you to take a small syringe and a big syringe and I want you to connect them with a little pipe. Try to push down on the big syringe, but I remember it has to be filled with water. Try to push down on the big syringe and you will notice that it's really difficult. When you push on the small syringe, it is very easy. Why does this happen? And we're going to look at a bit of science now, so we're going to nerd out a bit here. Newton's third law. It's a law that you will learn in high school. It says that for every reaction, there's an opposite and equal reaction. Now, what on earth does that mean? If you look at these two syringes I've got in front of you here, the one is the small syringe and the other one is the big syringe. The small syringe has got, let's say, for example, 4 water particles in it. The big syringe has got 8 water particles. So when you push against the small syringe, you will only feel 2 water particles pushing against your finger. So it's so much easier to push 2 water particles. If you should push the big syringe, you would feel all 8 water particles pushing against your finger. It's much more difficult to push 8 water particles than to push 4. And that is why you feel this big difference. That is why it is easier to push a small syringe than it is to push a big syringe. So if you want to maybe search on Google or find out a little bit more, I'm just going to say it again. It is Newton's third law of motion. Every reaction has an opposite and equal reaction. So if I push in one direction, whatever I'm pushing is going to push back onto my finger. The small syringe has got a few water particles that pushes back on my finger, while the big syringe has got a lot of water particles that is pushing back on my finger. Right, next. If I push down on the small syringe will, for example, move 2 centimeters, and the big syringe will always move much less, for example, 1 centimeter. And that is why if you have an hydraulic system, you will always have the small syringe that can move a long way, while the big syringe will always move half of it or much less than the small syringe. In the real world, this usually works, for example, in the jack. Do you see that it has an oil reservoir? And do you see that wherever you do the pumping motion, there is a very small, let's call it a syringe, a very small syringe part right here. So when you push down on the jack, the oil reservoir where the extra oil is goes into the small syringe and pumps into the big syringe over here. And that is why a jack can move up at small little steps. It's because the oil from the reservoir goes to the small syringe, and from the small syringe goes to the big syringe, lifting up something like a car very easily. The next one I want to show you is car brakes. When you push on the brake lever of a car, the small syringe transfers hydraulics to the big syringe there at the bottom by number 5, and that stops or puts the brake calipers together and stops the wheel from moving. If you had to push and stop the brakes with your foot without the hydraulic system, it would be impossible. But it feels so easy for you to press the brakes at 100 kilometers per hour because of the small syringe going to the big syringe, going to the wheel and braking it. So that's how hydraulics is used in the real world. You can always experiment with this by taking a big syringe and connecting it to a small syringe and seeing what the differences are. You could also challenge your friends and see if someone can push you away if you are holding onto the small syringe and someone else is holding onto the big syringe. So that is hydraulics and pneumatics.